Can you imagine a future where transportation is ultra-efficient, powered by cutting-edge design and sustainable infrastructure, all while being governed by a complex mathematical equation? Picture a world where our trains, planes, and automobiles are not just machines but intricate systems brought to life by the elegant dance of numbers and equations. This is not a scene from a science fiction movie but a potential reality that lies within our grasp. The transportation sector is ripe for revolution, and the catalyst for this change? The McGinty Equation, or MEQ. A formula that, at first glance, may seem like an abstract piece of mathematical art, but in reality is a powerful tool with the potential to redefine our understanding of transportation systems. From the way our vehicles are designed, to the infrastructure that supports them, the MEQ could be the key to unlock a new era of ultra-efficient, sustainable transportation. So, the question is, how can the McGinty Equation play a role in shaping this future? The McGinty Equation in its simplest form is piece xt equals sign piece qft xt plus piece fractal xt dm qs. Might sound intimidating, but let's break it down. This equation is a mathematical representation of the universe's underlying mechanics. It is a blend of quantum field theory and mechanical systems, represented by the terms psqft xt and piece fractal xtdmqs, respectively. Let's start with piece qft xt. This term is the solution of the free quantum field theory. In layman's terms, it describes how particles and forces interact in the universe. Quantum field theory is a cornerstone of modern physics, a language that describes the world at the most fundamental level. Next we have piece fractal xtdmqs, representing mechanical systems. This term introduces the concept of fractals, complex shapes that can be split into parts, each of which is a reduced-scale copy of the whole. In the context of the McGinty Equation, it's the self-similar structure of the universe that this term is trying to capture. But the McGinty Equation doesn't stop there. It has been modified to include the gravitational effects, leading to a more comprehensive equation, piece xt equals sign piece qft xt plus piece fractal xtdmqs plus piece gravity xtg. Here, piece gravity xtg represents the perturbative effects of gravity on the quantum field, with g characterizing the strength of the gravitational force. This modification is an attempt to reconcile quantum field theory with general relativity, the theory that describes gravity. The fractal potential term VYIT in the equation has a self-similar fractal structure, described by constant parameters. This correction term can be derived using integral calculus, Laplace transform, and the convolution theorem. So when we look at the McGinty Equation, we're not just seeing a string of symbols and letters. We're seeing a mathematical model that captures the essence of the universe, from the interactions of the tiniest particles to the effects of gravity on a cosmic scale. So essentially, the McGinty Equation is a blend of quantum field theory, mechanical systems, and potentially even gravity. Now you might be wondering, how does this equation apply to transportation? Let's venture into that. The McGinty Equation, or MEQ, is not just a complex mathematical formula, but a principle that can be applied to various fields, including transportation. It provides us with a new lens to look at how we design and manage our transportation systems. Consider the MEQ's dual components, the quantum field theory solution, and the fractal potential term. The quantum field theory component represents the unencumbered, free-flowing movement, a state we desire in our transportation systems. On the other hand, the fractal potential term, with its self-similar structure, mirrors the repetitive patterns we see in traffic. The ebb and flow of rush hours, the predictability of certain routes, and so on. By combining these two elements, the MEQ can help us understand how to optimize energy use in our transportation systems. It can guide us in creating designs that allow for smooth, uninterrupted flow, thereby minimizing energy wastage. But there's more. The MEQ also includes a perturbative effect of gravity, represented by g. In transportation, this could be interpreted as the external factors that impact the system, weather conditions, infrastructure quality, or even socioeconomic factors. By considering this in our designs, we can create systems that are more resilient and adaptable. Further, the MEQ's fractal correction term, derived using integral calculus, Laplace transform, and the convolution theorem, can provide valuable insights into reducing waste and enhancing system performance. It can help us understand and predict patterns, allowing us to anticipate and manage traffic flow more effectively. So, the potential of the MEQ in transportation is vast. It can guide us towards creating ultra-efficient systems that optimize energy use, reduce waste, and improve overall performance. It can help us make our transportation systems more sustainable and resilient. In essence, the McGinty Equation could be the key to unlocking a new era of ultra-efficient and sustainable transportation. So, what have we learned today? We've delved into the deep complexities and intriguing nuances of the McGinty Equation, a mathematical marvel that holds immense potential for the future of transportation. We've discovered that the equation, in its raw form or its modified version, is an amalgamation of quantum field theory and fractal mechanics, with a sprinkle of gravity's perturbative effects. The McGinty Equation, or MEQ as we've come to know it, is not just a string of symbols and parameters. It's a blueprint for an ultra-efficient and sustainable transportation system. The equation's knowledge, when combined with cutting-edge vehicle design and infrastructure, could revolutionize how we travel and transport goods. The PESQFTTT component of the equation, the solution of the free quantum field theory, represents the fundamental workings of our universe at its smallest scale. This knowledge can be used to design vehicles and systems that work in harmony with these natural laws, leading to unprecedented efficiencies. On the other hand, the fractal XTDMQS component introduces the concept of self-similarity and fractal structure into the mix. This could lead to innovative design principles that mimic nature's own patterns and structures, yielding both aesthetic and functional benefits. Finally, the P's-gravity XTG component highlights the influence of gravity on the quantum field. By understanding and harnessing this effect, we could potentially reduce energy consumption and increase the speed of transportation. In summary, the McGinty Equation offers a holistic, scientific approach to reimagine and redesign our transportation systems. It opens up a world of possibilities, from ultra-efficient vehicles that consume less energy to smart infrastructure that minimizes congestion and maximizes flow. But the true beauty of the ME lies in its potential to create a sustainable future. By tapping into the fundamental laws of nature, we can design systems that are not only efficient and effective, but also in harmony with our planet. With the McGinty Equation, we are not just imagining the future of transportation, we're creating it.